Hi, this is Charlie Bullock, and I'm going to be showing the completed practical part of my IRP assignment. This is based upon the completed research design side for part 1, and I was intended to develop a procedurally generated voxel cube terrain in an interesting way. The method I had set out to do this through was via layered Perlin noise alongside using the diamond square algorithm and combining them in some form. I believe what I'm going to show has fulfilled that. Additionally, I had other requirements. This included being able to remove and add blocks to the surface of the terrain, procedure generated terrain, along with having loading and saving in. So we're going to first take a look at the loading and saving. So at the start we just got simply layered Perlin here. We're going to keep that on, and we're just going to allow loading and saving, and you'll see what happens. So it will take initially at the start, especially when it loads something, a little bit of time because it's having to actually load the data in. But now, as we can see, this is a file. It's stored in app data under I believe it's CAB games under the heading, and this would store the chunk data, and it's F4 to save and F5 to clear a save. So that's the way it's saved and loaded respectively. And this is also done on it utilizes multi-threading, all of this as an option, and that includes the loading and saving. So quickly, what you can see here, we can remove blocks, we can place blocks down, we can choose different types of blocks. This also includes transparent blocks, which means that it actually will check if a block is transparent and not remove faces around it accordingly. You can see there's like a set kind of loading distance on the voxel terrain, and currently we're just using 2D Perlin noise. Oh no, sorry, we're using layered Perlin noise as our noise type. So we're going to close this a second, and then we're going to not do any loading and saving. What we're going to show instead is the Perlin noise, just quickly, so you can see what that is. This is just as I said, simply 2D Perlin noise. The layered Perlin noise just loops through layers which have offsets on them, and currently there's 3 layers, which is what you saw prior. You can also see that I've gone through and added in different types of vegetation. These are structures. These generate on top of the procedure generated surface, and these are kind of randomly scattered. So you can see like they're based upon height layers. So there's like you can see the height of the cactuses and the sand. So at a certain point above that, these shrubs generate. You can see there's some kind of spruce wood, some redwood, and some oak wood. This is just to kind of demonstrate how it can work and the possibilities of making the terrain more interesting. As that was kind of what I set out to do in my ARP, was to find ways to make it engaging and interesting to players. Through my research, I wanted to kind of make sure that I developed that in my practical side of this assignment. We're going to go now on to another type. So we're going to do the diamond square. This is a work in progress one, but you can see the diamond square algorithm somewhat working in that it does create terrain with the pattern of diamond square. So it's a bit slower, but you can see there where it's if it's best if we look from above. So if we take a look at the terrain, you can see from below the diamond square kind of pattern in above. You can see it there how it works. And for the main part, which is combining the layered Perlin noise with the diamond square algorithm, it generates some quite interesting unique terrain, which I'll show now. So that's here, and once this loads, you can see what it does. So here we can see the combination creates this quite interesting and kind of unique shape. It's almost like a very, very strong cliff. You can see the gap between where the kind of two terrains kind of collide, but it does it in quite an interesting way, which causes quite like kind of unique terrain to generate. So you can see there's like almost like a highland and a lowland. Furthermore, I implemented based upon an example of as found online, which was 3D purling noise, and I've used that for lots of different types of ores and stones, which I'll hang on a second, but I'll show that now. This may take a while to load because it'll be needing to generate a lot of things in the background, but once it has loaded all the chunks in, then it will work fine. It's just the initial load. If there's lots of things it needs to do, it will take a while. So you can see the chunks being loaded in now. So obviously there's the chunks that are around the player that are the ones that are rendered. Chunks away from the player are not rendered. I think it's built in like a 5 block distance currently. So you can see it started to load, and what you can see is it's best if I show it through this view, is you can generate using air gaps between ores and other rocks and sand and clay. You could generate these kind of very interesting like caves and narrow passageways. This would be quite interesting terrain for players, and you'd be able to engage them, which is something I was wanting to kind of seek to do as part of my IRP, and creates from what I've read, the procedure generated terrain needs to be engaging to players and interesting. If it's too repetitive, and it can sometimes be boring to players and lose their interest quicker than the benefits of procedurally generated terrain. That's most of what I've done. This uses a texture atlas for the blocks, so all the different block types reference a single texture, and they also have each block has its own like block ID, which you can kind of see here, like block types, and this will reference a, as I said, part of the texture atlas, like a position, or less of a position and more of a point. So it will know that 40 is the 40th kind of texture square on the texture atlas, and obviously it can do specific ones for each of the 6 faces of the voxel cubes, and as well it has checks for if it's solid or transparent. So for example, air is obviously a non-solid. Okay, so that's what I've done for my individual research project. Thank you very much for watching.